But if you have a question, maybe goodness could just let me know because I wouldn't be able to see. Yeah, I wouldn't be able to see your hands from my end. Okay. So thank everyone for joining once again. And I really hope feel free if you have questions at any time, just probably raise your hand. But you can probably like interrupt me once I hear just okay. So last week we spoke about cloud fundamentals, and this week we'll be talking about cloud security, especially about protecting data in cloud. And what we'll mainly be talking about, we're talking about cloud security, what's cloud security, and some key concepts of, and components of cloud security. We'll also take a look at the shared responsibility model. I think Fortress spoke about that last week, but we'll just revisit it and touch on it because it's really fundamental too for security. We'll also look at some common cloud security threats, also some best practices, and then we'll end the session looking at some case studies and some cloud security trends. Okay, so I think we could start the session. So first, what is cloud security? A very basic way to define cloud security is just the protection of data, infrastructures, and applications in cloud. So cloud security is very critical, especially in today's IT infrastructure, because a lot of organizations and a lot of individuals are actually moving to cloud, as Fortress explained to us in our last class. So because of that, we really need to find a way that we can protect the cloud at the same time. And why this is very essential is because number one, because of data breaches, there have been so many cases of data breaches, and we'll see some of them in today's case studies today. I'm sure some of us should have remembered Uber's phone, which happened, I think, in 2022. We have some very other significant data breaches that have happened, like Capital One, and there's so many. It's a long list, and it really creates such a very big alarm, and it's really essential for us to secure the cloud. Another reason is compliance. I think compliance is very, very important because organizations and people, especially when you are building applications, providing services to people, you must really adhere to a lot of regulatory compliance and industry standards because it is very important to protect people's data. Sensitivity is very important. For example, in Europe, different countries, different countries majorly have their own compliance regulations and compliance. For example, in Europe, you might have GDPR. Um, Japan has their own, the Privacy Act. China has theirs, where you can't even, for example, if you are operating in the China region, you can't move the data out of China. You can Russia is also like that. So so many other countries like that. We still have PCI DSS for payments. We have HIPAA for organizations in healthcare. So and the thing is, non-compliance can really lead to like hefty fines, a lot of legal consequences. We have seen even like a lot of big tech companies suffering legal consequences due to compliance. And the last reason why cloud security really matters is trust, especially as from the perception of your customer. You really want your customers to have confidence in you, and maintaining a very robust cloud security. It really helps to ascertain that. So you want your customers, your partners, people that are providing services to really trust you. Another reason is because of your reputation. So you really want to preserve your reputation. So these are just few reasons why cloud security is really important. There are so many other reasons from even economic impact. Can talk about today's landscape of threats. But one thing I would just really like us to gain from this slide is that cloud security is really modern, is really important for modern IT infrastructure. I think that's really the point I want us to gain from this slide. And it is vital for protecting sensitive data. One notion I've really seen a lot of people when you mention cloud security, a lot of people always think it's just infrastructure as a service, IaaS, but you have to secure your cloud across every tile. So from the SaaS point of view, down to pass, down to even IaaS too, which is really essential. Yes, they have different procedures for how you protect security in SaaS or security in IaaS or PaaS. They are definitely different, but cloud security encompasses all of that. So it's not just about AWS or Azure. If you are using like a SaaS provider, we are using Dropbox, or you are using Gmail, it's also considered part of cloud security. So let's talk about the components of cloud security or the key concepts of cloud security. Has anyone here heard of the CIA triad? I don't know if everyone is familiar with that. Probably someone has like a security background that is a bit familiar with. Okay, okay, so I can see a few hands up. So that also extends to in cloud security. Okay, I think yes, Olaoluwa, you have your hand up. You also have a question. Okay. All right. So the CIA triad is also really essential in cloud security too. It's basically fundamental of security and it really extends to cloud too. So the CIA triad comprises of three fundamental points, which is confidentiality, integrity, and availability. And each of these, they have different ways of implementing them. There are so many ways of implementing confidentiality, integrity, and availability. I will talk about that. But this is basically the CI trial. Okay, so first, let's look at confidentiality. So confidentiality is basically ensuring that you are preventing unauthorized access to data or yeah, that is stored or processed in the cloud. So that's confidentiality. Whoever should not have access shouldn't gain access. That's basically it. I shouldn't be able to gain access into witness data in the cloud without him giving me authorization. Or I shouldn't be able to see probably benefits data in the cloud without him giving me trust or like authorization. That's what this confidentiality is. As long as goodness or benefit decide that they don't want to release this data or information to me, I have no right seeing that information and data. So basically, that's what confidentiality is. As some common technologies we use to implement confidentiality include encryption. I'm sure you've heard of encryption. So either you're encrypting data in transit, probably by using TLS, HTTPS, or you're encrypting data at rest. You could be using services, for example, AWS, Azure, they have their KMS, key management service, where you can manage encryption keys. That's a really good way of maintaining confidentiality. Because when you encrypt data, people without the keys are not able to decrypt the data. Another way of ensuring confidentiality is access control. And access control is also a very, very vital thing in cloud today. So access control includes using identity and access management, IAM. I'm sure it's something we've also heard of before, to define and enforce user permission. So ensuring that a user has authorization by using policies, resource policies, IAM policies, as part of access control. And one I'm sure we'll be really familiar with is MFA. MFA is also a very big backbone in maintaining cloud security. It's like confidentiality because it has an extra layer by enforcing a second form of verification. So without having the second form of verification, no one should have. I'm sure there are so many ways we use MFA from our social media networks to probably our organizational resources. This is also so when you hear MFA, it points to people trying to maintain confidentiality. So now we're going to the next one. Let's talk about integrity. So what integrity basically does, it ensures that your data is accurate and unaltered. So the way you leave your data should be the way it is basically. So for example, if probably Shisom is sending me something, um, it should not be altered in the process of her sending it. It should be the exact same way she's sending it. For example, I'm sharing this presentation to you. You can all see my screen. If I'm sharing it, for example, in the group chat, it should be exactly this way. That's integrity. It should not be altered in um, a specific way, and it should be accurate. Now, some technologies used in the cloud to also implement integrity. We have hashing. Hashing is also like the border of encryption in a way. We have encryption hashing and tokenization, they are basically related because what they do is they all basically transform data from plain text to ciphertext, but they work like in very different ways. So hashing is for integrity. So what hashing does, it validates the integrity of files. So you can use it to like validate integrity of files uploaded to the cloud. For example, each file, if you notice, if you have a particular file, you can always generate a SHA-1 value for the file. Now you checking that or SHA-256 value. You checking that SHA-256 value. For example, you just adding a simple A or probably B, or just adding a simple word like D or something, it's going to change the value of that. It's going to change the value of that SHA-256 hash. So you could change it by some letters. That's how you know that okay, this data has been altered. So that's how hashing comes into place. Another very strong way that people implement integrity versioning. You implementing data versioning, you can easily track changes. And in case you notice that okay, something has been altered in the process, you can easily revert to the previous version if it is necessary. And for example, if you are familiar with S3 buckets and blobs, you can enable versioning in your AWS S3. This will help you to like keep a track of like your object changes. Also, in your blogs, you can do that. Also, if anyone is familiar with like DevOps, we'll also be having a class on that next week. But for example, using things like GitHub, you can also maintain versioning in environments, even down to like Terraform. When you do like tools like Terraform, you can maintain like versioning, and if you notice, okay, someone has like altered something specific, you can always just reverse the previous versioning. And versioning is very important, even like maintaining CI/CD pipelines. And lastly, in integrity, we also have digital signatures. So digital signature is basically to verify the authenticity and integrity of messages or probably data or documents. And as anyone here heard of AWS Cloud HSM, as you also have their own basically has anyone okay basically has anyone heard of an HSM before, hardware security module? Okay, so HSM or cloud security module, it's commonly used to keep encryption keys. So on there's the hardware version of it where you can basically keep the encryption keys, but there's also the cloud version of it. So AWS, Azure, they both have their own different HSM service. But one other thing that HSM is also used to do is you can use it to also sign and verify data. So you can use cloud HSM to generate it to sign data. So once you maintain a signature of that data, someone can easily see that okay, yes, this data actually came from this source. So probably I want to present this probably yeah, I want to share this presentation with you and I want it to be confidential. I can use HSM to sign it, and then you on the back end, you also have like the right HSM decryption technologies in place. You can also verify that okay, this signature actually occurred from Adidas. So you have tools like that maintaining digital signatures. And lastly, availability. Now, availability is very important. I'm sure you all hate it, for example, when you're trying to use a service and then you notice that for some random reason it's not just working, or you can't access, for example, I remember all those like Twitter outages. Imagine you're trying to like do something on like Twitter and then you realize that for some reason Twitter is not just coming up, or you're trying to like use probably yeah something that is very common in Nigeria. You can see your bank apps to transfer money, and for some reason it's not just working. So that's where availability comes in. So availability ensures that data and services are accessible when needed. This is very fundamental in security. It's really important to consider that it shouldn't be, yeah, there can be downtime, but it shouldn't be at a prolonged level. You really want, because number one, due to like customer satisfaction, you really want people to be happy. At the same time, you really want people to be able to use the technologies optimally. So it is always very important to ensure that data and services are accessible when needed. And some of the ways that you implement availability in cloud security, first, we have redundancy. So I don't know if anyone has heard of redundancy before, where we are replicating data in two or more different places. For example, S3 is very common with S3. You could replicate, we call it, there's cross-region replication where you could replicate your data across regions. We are also using other like tools, like for example on AWS, we are using like RDS. You can deploy your RDS in like multiple availability zones. And yeah, that's just a way to ensure that okay, yes, so data is always available. Because for example, if one region is down or one availability zone is down, you can easily just switch to the next availability zone and then your data is still there. You're basically using the same data. So that's where the redundancy comes in. Auto scaling is just basically you um, ensuring that objects are able to scale up or scale down. I think I remember Fortress also spoke about this briefly in last session. So you ensuring that your services are able to adjust based on the capacity and based on when it is needed. So, for example, you can implement auto scaling by using EC2. By familiar with EC2 instances, you can define an auto scaling group. Okay, when your CPU utilization is at this level, you want more EC2 instances to be, or when you notice a spike in traffic. For example, you have a web server, and that web server is like professing like yeah, it's basically you have a website on the web server, and you notice probably it's like an e-commerce website here, and days like Black Friday, you see that a lot of people really want to buy serving yeah, buy a lot of things from that website. You can easily implement an auto scaling group that will tell you that okay, probably when there's a certain amount of traffic, you want more EC2 instances to be generated, and that's way people are not going to experience downtown at the same time. And another way you can also implement it is load balancing by using load balancers. So the load balancer, what you do is we notice that okay, yeah, there's certain traffic already going to this EC2 instance. You can easily switch to another EC2 instance. And lastly, disaster recovery. So you have tools like AWS backup, AWS disaster recovery. It can help you to develop, and you can also like test disaster recovery strategy. So basically, this is basically the key concept of cloud security. Most of the technologies, tools, services that you're going to be using, they all revolve around these three, ensuring that your data and customers' data is confidential, ensuring that data is accurate and not altered, and ensuring that data is always available at the right time and services. So I'll just ask to ask, does anyone have any questions so far? If I go to the next slide. Okay. All right. So now we can talk about the shared responsibility model. Fortress showed this in the last class, but it's really really important for security. Because we are going, yeah, when venturing to cloud, probably migrating or using the cloud, you are going to definitely use a specific deployment model. It can be infrastructure as a service, platform as a service, and software as a service. So when using these three, it's important for you to really understand your responsibility and the cloud provider's responsibility. And cloud providers can be different organizations. For example, infrastructure as a service, that's where people like Azure, AWS, Alibaba, Oracle, they fall in. Pass as a service. Also, yes, for example, AWS has some pass as a service applications. For example, you have like Elastic Beanstalk, you look at Lambda function, Azure function, but there are also like platform as a service providers too. And SaaS, which is very, very common. For example, Gmail, Google Meet. Also, when you're using things like you have like an exchange online, or you can even have like a security service as a SaaS provider. So you're definitely going to be using one of these. But the same one thing that really causes confusion is people always tend to, although that's changing, but in the beginning, people always used to tend to believe that a lot of responsibilities on the provider. They're the ones that develop the service. They're the ones that that are providing the service. So they should be the one providing security. But really, it's not that way, and it's different across different services. One thing that I would really like to emphasize or stress is one thing that you can never outsource, regardless of the deployment model you're using, is governance and compliance. So you have to really maintain governance and compliance in your organization. in your applications, once you are building, definitely you can't outsource that. For other things, yes, there's a bit of shared responsibility between a lot of them. So first, if we look at infrastructure as a service, we can see that from the cloud provider takes care from the hardware to the OS. But everything on top of that is basically the customer responsibility. So as a cloud providers will take care of, yes, data centers, they'll take care of the AMIs, the machine images, they'll take care of the SDNs, software defined networking, they'll take care of virtualization, basically everything underneath, they'll take care of that. But you have the responsibility of what you're building on top of this. So, for example, maintaining your network security, that is your responsibility. You have to, especially when you are using infrastructure as a service, you have to ensure your VPCs are correctly configured. You have to ensure that security groups, access control is they are correctly configured. Access and authentication is also your responsibility. You have to determine who has access into your cloud environment, into your infrastructure as a service environment. Operations is also your responsibility. Identity, maintaining identity is also a responsibility. How do you want to do that? Do you want to use federation? Are you using the cloud native services? Are you using an on-prem service? It's you have the responsibility over that. Down to basically the web application security, the deployment, how you deploy things on the cloud, using how you deploy institute instances is your responsibility. How you use the cloud is also your responsibility. How you grant policies, for example, policies to your services, policies to your resources, is also your responsibility. Contents of things that you maintain on the cloud is your responsibility in infrastructure as a service. Now, if we move to platform as a service, there's a bit of gray line. There's always a bit of a gray line. So it depends on like the platform of the service that you are using. For example, if you are using a database, the responsibilities might be shifted a bit more to the cloud provider. Sometimes the responsibilities can be shifted more towards the customer. So it really, really, there's always like a gray line in between. But a good way to just understand is that, and this is was gotten from GCP. So GCP explains that for platform as a service, the cloud provider maintains everything from hardware to identity. But basically, every other thing you build on top of it, the customer is responsible for that. But like I said, it also depends on the kind of platform as a service you are using. And lastly, is SaaS. Now, SaaS is where, as a customer, you have the least responsibility. So you really don't have to like maintain a lot of things. But one thing that is very, very important in SaaS is maintaining your data. And that's one thing that should be very stressed. So when you are using software as a service, you should really ensure that you have full control of your data. You ensure that your data is being backed up. Ensure that you can easily export your data. Ensure that in case of vendor locking, or probably if the vendor you're using is sold to another organization tomorrow, you can easily export your data, and you have to like switch to a different vendor and really do that. So that's one thing that is always like a big thing that should be stressed in SaaS. Yes, the provider will take care of a lot of things. For you as a customer, you really have to ensure that your data is in place. And you have to determine, okay, who has access to this data, what content are you putting on this data, how do you use this data. So this is this is your responsibility as a customer. So like I said, one thing I really like to understand is that cloud security isn't just present in infrastructure as a service alone. Yeah, when you hear cloud security, people can tell you are working on technologies like AWS, Azure, but honestly, it extends beyond that. You have to also ensure that your platform as a service is secure. You have to ensure your software as a service is secure, because all of these three deployment models are all an aspect of cloud. Yes, infrastructure as a service is more common, and probably platform. Yeah, all of them are even very common, honestly. But at the same time, you have to ensure that you are maintaining security over the three, and that's what cloud security is about. So, is there any question on this slide? Okay, okay, so we'll move to the next slide. So, the next slide, we're going to be talking about some common cloud security threats today. And the first one is misconfigurations and adequate control, change control. Misconfigurations is basically one of the major reasons for like a lot of cloud data breaches and a lot of incidents in cloud the misconfigurations where people don't assign the right policies, where services such as S3 or yeah, different services are not configured rightly. It's a very big threat today, and it's so a very big risk. And inadequate change control, where people cannot monitor the changes, where people, for example, you see a lot of scenario where an organization has deployed something, and there's no regular like auditing to see, okay, um, where can we look at some areas where changes have been made, or look at how they can like make things better or how to streamline things. You usually see people where they just like configure something and that's it. They never go back to revisit it. And this is very alarming because every day new technologies are evolving. Even to the existing services, things like S3, um, WAFs, every day there's like new things that are really being built up, on top of them. For example, network of AWS network firewalls is something that came a lot later after WAF. But a lot of people, you see a scenario whereby a lot of people don't even go back to revisit. Okay, since we have network firewall, how can we utilize both AWS network firewall and WAF at the same time? People just believe, you know what, when WAF is like, has been configured, that's enough and we're just going to use it. But it's really important for you to have a change control to like understand that okay, yeah, changes are being made on a regular basis. How do we keep track of those changes and how can we maintain that? Another really common cloud security threat is insecure interfaces and API. So we have your interfaces basically comprised of your management plane. The management plane can be your AWS console, basically is an interface. So whereby people are not, for example, you see scenarios whereby people are using their root accounts to basically provision things on their AWS or Azure service, or even their SaaS service. You see people using the root account, and that is something that is a very big red flag. Um, One very best practice in cloud security, they tell you that once you have like access to your credentials, they believe you should lock it, just lock it, create a new administrator that has enough privileges and just lock your root credentials. Your root credentials should only be for um cases of like incidents where you need like an overall visibility of things that are happening. But you see a lot of people they just feel okay, yeah, can easily use the roots, and it's very alarming because once people gain access to your root account, you basically have access into everything. So we see insecure interfaces like that, and API security is something that really needs to um, be looked after today because even the cloud is basically built upon APIs. I don't know if everyone has heard of this Jeff Bezos API rule. That was basically like the backbone of how AWS was created. You even using like AWS services, you're basically just calling APIs, but you're just doing it over like a console. You're doing it over an interface, but at the back end, you're basically just interacting with APIs. So that's something that we really see as a big threat. A lot of APIs, you see people that will create APIs and APIs have full access. APIs should also be like streamlined. APIs should not be able to like go across overboard across why they were created. So if you need an API, for example, you want an API to be able to for an S3 bucket, yes, to be able to like get data for an S3 bucket. That API shouldn't be able to also upload data at the same time. But that same API should not be what is used to like access things in like your EC2 instance or get your EC2 instance metadata. It shouldn't work that way. API should be really streamlined into like what were they created for, what are they being used for. Another very big common scenario in cloud security is also data loss. We really see a lot of scenarios where customers' data are exfiltrated. For example, remember the Uber case, a lot of data, personal identifiable information was exfiltrated. And so many times you see this data being sold into like dark web, and this data they usually have harm. And a very interesting thing even happened in like the beginning of the Uber case. I'll talk about the Uber like case shortly. But you will see how like data loss is really like a very big common cloud security threat because it was due to data loss that they were able to gain like entry into Uber's environment in the first place. Another threat we see is also account hijacking. So whereby people are able to like gain access into other people's accounts. Well, and this also goes back to things like misconfiguration, where people are not using like proper access controls, where people are not maintaining proper passwords. And yeah, people are basically able to hijack their account based on this. And it also goes to data loss because you see a lot of data being sold on the dark web. So people are able to easily get passwords. For example, if you have to like join the Reaper, like a database, you can easily use it to, like or hash cards. It has like enough passwords that you can easily like just easily use to brute force and like get into different AWS accounts. And insider trades too. A lot of organizations they have like people that can sometimes can be intentionally or it can also be unintentionally in the sense whereby people can accidentally like leak data at the same time. So this is something that is really should be really stressed in cloud security today. And there are so many more. There are so many more. There are zero-day exploits, even in cloud. There are a lot of zero days now. Sometimes you don't see a lot of you might not see the vendors disclosing it, but it's really becoming a big deal today in cloud where there are a lot of like zero-day exploits. There are so many threats, but these are just some of the common ones. And this really tells you why cloud security is really important because we really need to be able to meet up with these threats. We really need to be able to find a way to like provide a solution to these threats. And without knowing how to secure the cloud, we wouldn't know how to also provide solution. Okay, so let's just talk about some best practices in cloud security. These are just some best practices, like basically the basic. So the first thing I'll really consider like the best practice is architecting the right and secure way. I feel that's really one of the backbones um, in cloud security. You being able to architect your cloud infrastructure in the very right and secure way. For example, if you want to use infrastructure as a service, okay, do you want your infrastructure as a service to be connected to your on premises? How do you architect that? How do you ensure that okay, if they're going to be talking to each other, the data can still be segregated? Are you going to maintain something like a bastion host? Are you going to use like a spoke model or like a hub model? You know, understanding okay, how do you architect this? Another way, even in SaaS, for example, okay, you are going to be using a SaaS provider. Do you want your organization to be directly accessing the SaaS provider over the internet, or if first you use a proxy, you prefer to talk to the SaaS provider using a proxy? Those are things people really need to consider in cloud security. And one very common thing that people do, especially when migrating to the cloud, you see them just lifting and shifting. So lifting and shifting in a scenario whereby whatever they have on premises, you just see them, they just copy it and just paste it in the cloud. That is like a very, very bad practice. If you know you want to migrate to the cloud, it is very essential that you first look at your existing on-premises process and then look at the cloud infrastructure. How do you want to build this cloud infrastructure? Then try and identify limitations and gaps and how can you like close these limitations in the cloud? Because that's one very good thing about the cloud. The cloud really gives you a very good way of closing limitations that you might not have even noticed before. But how do you do this? You have to do this by learning how to architect the right way. And this has also led to a lot of like other um creation of new job roles. For example, we have like cloud security architects today. Yes, someone do this kind of job roles, they entail like a lot of experience, but it's also like a really interesting thing to look at. So yeah, architecting the right and secure way is a very good best practice. And there are so many things that can help for that. For example, one very common thing, you have a well architected framework. Um, you could always refer to documents like that. We also have like third-party providers that will also like release documentation for how to architect in the cloud. You can use a cloud security posture management tool to also help you like gain visibility into your cloud services and how it's working. Another thing you can use like cloud CASB, cloud asset security brokers. We are using something like AWS to have control tower. Control tower is very, very good. Especially if you are moving to cloud because control tower already has like templates of like right and secure ways of you to be able to use the cloud. So you can easily just refer to control tower and control tower will like easily spin up a very, very secure and well architected infrastructure for you. So those are ways that you can really architect and secure the rights. So also referring to documentation and also like employing the right people, ensuring that you have like the right team to help you to architect. Another very essential best practice is securing the management plane. Now, the management plane is like the biggest difference between the on-premises and cloud environments. And what is the management plane? The management plane is basically the console or the APIs, the CLIs, or probably even the SDK. That's what the management plane is. So on normal day, on premises, you don't have a management plane. Yeah, you have for you to provision things, probably have to like plug into the server to make changes into the server or RDP into the server. But the cloud gives you a management plane. You're easily able to talk to your infrastructure using API. And it is very, very important that you ensure that the management plane is secure. So if you are using the console, it's very important. Ensure that only the right people have like access to it. Ensure that um you're not using root credentials. Ensure you're not giving. Ensure you're using principle of least privilege. If you are using APIs, to ensure that the APIs are really secure. If you are using access keys, ensure that the access keys are also secure. Secure. Ensure that your credentials are not hard coded. So the management plane is really, really essential because honestly, if an attacker or anyone has access to your management plane, they have access to your entire cloud infrastructure basically already. So it's very, very important that you ensure that your management plane is secure. Also, access controls. Basically, we spoke briefly about that in the in the third slide. So access control is really, really important to implementing this privilege, ensuring that people don't have more privileges than they should have. And even in scenarios whereby you want people to have additional privileges, ensure that you can utilize things like rules where someone can just assume a role and then use the service that they want to do. And then once they are done, they can easily like log out of that role. And there are also tools you can use like check these rules. Okay, when was the last time someone actually used this role? When was the last time Adidas used this role to like access anything? And if you notice that he hasn't used that in a while, you can easily just remove people from that. So it's very essential to like ensure that you are utilizing your access control. Another very good best practice is also encryption. So ensuring that you are utilizing encryption as it's very common. Don't use HTTP, use HTTPS. If you have data, encrypt your data in your S3 buckets. There's this it's something that I plan to share after the presentation. There's this is basically site. It's not coming to my head right now, but it's basically a thread site where you have access to like a lot of public S3 buckets. Like you can see information. I'm telling you, you just go there and search for someone's name. You can even see things like people's CVs, and they're just there because people did not like properly ensure like encryption and access control in S3 buckets. So imagine how like your CV might just be out there, or like other personal information, things like salary, things like your pay slip, because organizations are using S3 buckets and they are not encrypting data, they are not ensuring that the right access control is there. So people's pay slips are just out there. You can just like search for a lot of things and then you're just seeing a lot of data. So that's why encryption is also important. Another very good best practice is ensure that you are regularly auditing your cloud environment. Now, auditing in cloud can be a bit different because you have a cloud provider. So in the first place, there has to be a level of trust between you and your cloud provider. And that level of trust comes from using things like third-party attestation. For example, checking if your cloud service provider is PCI DSS compliant, HIPAA compliant. That's one way of ensuring that okay, yes, auditing is in place. But at the same time, you also have the responsibility of auditing how you use your cloud too. So ensuring that you're always checking, okay, and this access control is still being used. Is this person is someone in our organization that has probably left or retired? Why is he still having access? Does he still have access? Does he still have access to like services he shouldn't have access to? As it will be deleted from the cloud plane? Have we ensured like processing to ensure that once someone is retiring, it's automatically like being deleted from the platform, or once someone is resigning, it doesn't have access to it. It's very essential for you that you are regularly auditing. And even the audits from the cloud providers, you should ensure they are regularly checking because auditing is only for a period of time. So ensure that they are regularly updating their audit checks, because you don't want a scenario whereby you think, okay, the last time you were using a cloud provider service, for example, imagine a scenario where the cloud provider released a new version of probably the solution you're using today, and then it's not PCI DSS compliant. Meanwhile, the last time you were using the product, the previous version was PCI DSS compliant. And you decided that, okay, you want to switch to this new version, probably because it is cool, it is more secure, and it resonates more with what you do. Imagine then you switch and then you have a third party audit in your environment and you realize that, oh, that they are not PCI DSS compliant. It's really going to cause like a slap in the face for you. You have no control over that. So it's essential, like even when you're using third party providers like auditing to ensure that they are regularly keeping their own audits like in place and you can easily always like check them. And also compliance checks. Ensure that whatever provider you want to use, ensure it is meeting the compliance and you are also meeting that compliance. Like I said, you can never outsource governance and compliance. You have to ensure that you are meeting the compliance. So if, for example, if you are developing applications for healthcare, ensure you are HIPAA compliant and also your cloud provider is HIPAA compliant. If you are using if you are doing something concerning like in Europe, ensure you are GDPR compliant. The provider is also GDPR compliant. So you always have to ensure that you are meeting up with this compliance check. Yes, it can be a bit taxing, but there are also rules for that. So, for example, another you have like GRC coming in, but you have to ensure that that's a very good secure practice in the cloud. And lastly, is having an incident response plan. You don't want a scenario whereby it is when an incident happens that you are now like running through, you're now like trying to figure out what's incident response contains of like different phases. So as the preparation phase, you should ensure that you have already like developed a comprehensive plan. Ensure that you have a plan in place already. Ensure that you start patrolling. Ensure that you have the right monitoring tool. In identifying, ensure you are using the right cloud native tools. If you are using things like CloudTrail, you are using Azure Security Center, ensure that all of these things are in place already. Also, ensure that you are regularly like reviewing logs. Ensure that you are regularly like checking for IOCs in your environment. And then when probably you notice an incident and you probably want to contain, ensure that you can easily isolate these services that have been affected. Ensure that you can use things like scripts, you can use playbooks to quickly contaminate this. Ensure that you can also like easily find the root cause of the incident. So it's a very essential that you have an incident response plan. And there are so many ways that the cloud has made it easy to have a great incident response plan. For example, you can automate a lot of things right now. You can use a lot of automation tools. You can also integrate your cloud security services with other security tools that can help you to like secure your cloud environment. At the same time, you can also like work with other like CSPs and stakeholders, like collaborate with them. And you can also ensure that you are meeting with relevant regulations and standards. So there's like a very important need for you to maintain vigilance and like ensure that you are regularly also improving your incident response plan because threats are always going to be there. And it can't be stressed enough that as new technologies that are coming in place, the attack surface is increasing, and at the same time, attackers are also getting smarter. And you, as a cloud security engineer, you also have to ensure that you are also getting smarter too. So your incident response plan should not be the same incident response plan you were using 2 years ago. Plan should be using. That's why you see a lot of organizations they have an incident response plan like daily. Daily. They're like like every year they regularly like update their incident response plan. So these are just some of like the best practices in cloud security. There are things that people will always like ensure that you have in place to ensure a secure environment. Okay. So is there any questions so far before we move on to the use case? Was there anything anyone like to contribute to or anything someone likes to highlight?
I had to do.
Okay, yeah.
Yeah. Because of time, so probably we'll just run through the case study, then we'll take questions afterwards.
Yeah. All right, no problem.
Yeah.
All right,
Thanks.
that's fine. Okay, so let's look at some case studies. So this case study is basically I didn't want to make it like elongated, so I just chose two very ones that were like very prominent in cloud security. So they are just real world examples of like notable security events. And so on this case, so we're going to see like how the attackers actually like gain access to like the environment of the organization. And we'll also look at some lessons learned, and we can easily tie it back down to like some of the things that we've been talking about. So first, let's look at the first case study is an organization known as Capital One, and this happened in 2019, and it's actually one of the like most notable cloud security events. Yeah, I think it happened, yeah, March 2019, but for some reason it wasn't disclosed until like I think July in 2019. And about 100 million customers were affected in the United States alone, and about 6 million customers were affected in Canada alone. And the way the attack was facilitated was by a misconfigured WAF application on AWS. I don't know if WAF, is anyone like familiar with WAF? Just like signify web application firewall. Okay, so okay, let me just give a brief overview of WAF. So what WAF is used to do is it helps to protect the web application on a layer 7, yeah, on a layer 7 level. So it helps with attacks such as SQL injections, cross-site cross-site scripting, or also attacks like denial of service. So that's where WAF comes in. So what the attacker did was he noticed a misconfiguration basically. So they didn't configure their WAF the right way. I didn't get a lot of like information on how it was misconfigured. They didn't disclose that, but there was a misconfiguration in their web application service, and from this misconfiguration, the attacker they were able to execute what is called an SSRF attack, which is the same thing as a server-side request forgery. So how SSRF works is imagine you hosting a web application on a server. Once someone is able to like execute SSRF, they are able to make server-side requests. So what they are able, so on a normal day, you shouldn't be able to like make requests to the server. You should be only be able to like access the application. But when SSRF comes in place, you're able to also make requests to the server. And you can make requests to even the domain, so you can get things like information about what kind of like the metadata. You can get metadata of the probably if it's a VM or if it's like an EC2 instance, you can get metadata of that. You can also get basically SLR exploits like a lot of information on the server side. So by doing this, the attacker was able to gain metadata service of an EC2 instance. So basically, they had an application hosted on an EC2 instance, and that was where the attacker gave the entry to. Now, for you to see like how we went further the line, from gaining meta service exploitation, at the same time, we're now able to gain like permissive IAM credential. We're able to like basically laterally move onto the obtain some highly permissive IAM credentials. And these credentials were now able to like gain access to like the S3 bucket. So people were basically so this S3 buckets had a lot of like PII information in it. Some of this PII information include people's personal information, their names, their addresses, phone numbers, email addresses, and also things like their credit scores, their credit limits, their payments history. We also had things like their social security number and their bank accounts of customers in the United States. This was how an attacker was able to like exfiltrate PII data, and basically everything was exposed. So some ways that they helped to like remediate this was first they reconfigured their WAF, so they were able to like tighten their security controls, so they were to prevent SSRF attacks. Also, they also conducted like a thorough review of their IAM policies. So they started implementing these privileges, like I mentioned, and this helped to ensure that only like the required people had like permission, the required services. They also improved their logging and monitoring, so people were able to like see what was going on in their environment. And they also perform security audits too. Like how we mentioned, that it's really important for you to regularly audit. I'm sure if they had probably done this before, they would have easily seen that something was wrong in the environment. But after this attack happened, to help like remedies, they performed an audit and they also performed penetration testing. And lastly, they also developed like an incident response plan. And this really tells like the importance of even having an incident response plan in the first place. So what are some lessons that were learned from the Capital One breach? Number one, it is very important for you to like properly configure your security team because misconfigurations can really lead to like a lot of vulnerability as you can see in this breach. Like it was just a simple misconfiguration in the web application firewall that led to gaining metadata data information, to gaining IAM credentials, to even gaining access to an S3 bucket, S3 data, all from like just a simple misconfiguration. So it's really important for you to ensure that in cloud security that you are properly configuring your tools and services. Secondly, is also we can learn that excessive permissions are very, very dangerous. So it is very important to ensure that you apply the principle of least privilege to like IAM rules and other security controls. Like this can be stressed enough. Like and also implementing things like MFA too is really, really important. Also, regular security assessment, like we mentioned, you regularly auditing your environment. You should also ensure that you conduct regular security assessments, ensure that you can easily audit and conduct penetration testing when required. And it is essential to like find ways to like you can remediate vulnerabilities. Yes, you can accept some risks, but there are also some risks that you should also be able to like meditate. There are also some risks to be able to transfer to like other service providers at the same time. And the good thing about this is also like creating so many like rules and opportunities. So it makes it very, very cool that cloud security opens a lot of like different rules. So you can be a penetration tester, you can be an auditor in the cloud, you can be on the blue team side. There are so many rules too that this opens, and this lets you know why professionals are really being needed because of like breaches like this. And lastly, also we cannot stress how like you really need a very good incident response plan. Like I mentioned in the last slide, it's very, very important that you have an incident response plan. If Capital One had this, they would have easily detected, not let me not say easily, but I'm sure they would have detected this like better and would have like provided solution for it on time. Now we can look at another case study. This was very, very popular. It was in 2022 and it was Uber. I think yeah, I remember it was in September 2022. And why it was really, really funny because how the attacker initially gained um access into the cloud environment was by gaining compromised credentials. And how he gained those compromised credentials was by he got it on the dark web because the contractors what's it called? The contractor's device here was infected with malware. So it was basically infected with the spyware. And using that spyware, they were able to get like credentials for that contractor and they sold it on the dark web. Now you can really see why data loss is a very, very big how security threat today. So many data is just out there basically, and people can really, really misuse this data and use it to like get so much about it. There's certain scenarios where people use things like their date of birth as their password or like their mom's name or like song close to them. All this data is out there. And especially in a country like Nigeria, where we don't really have like a lot of controls to our data. You can imagine how much of the data you can't even control, how much of the data is out there. So you can see how an attacker was able to like get compromised credentials from the dark web. The data loss is something really, really important. So when the attacker gained control, what he did was he was able to compromise MFA. So what he did was he sent a lot of MFA requests to the what's it called to the user. And then at the point, the user just got tired and he just accepted one of it because he just kept on getting the request. And then with this, was able to gain access to a VPN that was connected to their cloud services. And that was their GCP and their AWS. And this GCP and AWS had like internal services. They had like internal information in this and also their internal networks. Now, he didn't even stop there. Once he got into the network, he was able to get an EC2 instance and he was able to get a partial script. This script now had like hard-coded credentials, with these credentials, we was able to like gain access to Uber's PAM system, their privileged access management system, and that now giving like access to like a lot of their critical cloud resources, and at the same time, they're even their bulk bounty programs. Now, a lot of data were also like compromised, like a lot of sensitive data. Their internal code repositories were compromised. Their financial records were also compromised. Their operational details were compromised too, and also like their source code and like proprietary information. Imagine you as an organization having all of that in the open. It's really going to really cause like a big slap to your face, and also to like it's going to build a lot of like trust and yeah, and damage your reputation in so many ways. Now, some lessons that were also learned from this data breach is one, that is that it's very essential to like use robust MFA tools. Now, especially in scenarios like this whereby um you yeah, in scenarios where like this where you can easily get like flooded with so many MFP requests. Imagine we had a robust tool that or that said that okay, you know what, after 5 requests, you shouldn't get more requests, or after 3, because it's unusual, like why would I keep hitting no on an MFP getting more and more requests? MFA is very, very important, but at the same time, you ensuring you are using the right MFA tool is also really, really important. Secondly, we also have like regular security audits. It's really, really important that you are regularly like performing security environments, security sorry audits in your cloud environment. And lastly, we can see stress, incident response, and asset control. Now you can see how some of the best practices are spoken about, and some of the things we even spoke about, in things like the shared responsibility model, all came back to like breaches like this. Imagine if these best practices were already put in place. I'm sure these organizations will really not suffer a lot of this. And this is really, really useful information for people that want to have a career in cloud security. You learning some of these best practices and seeing ways you can really, really like implement them. There's so many ways, like I said, I will visit some of them shortly. But it's really essential that you know the best practices, know how you can implement them, and find like the easy ways that can make ensure that it is really, really easy for you, and also at the same time ensuring the best security for the user. So yeah, I'll just like to ask you any question so far.
Yeah, I don't know. So I think there are questions. How many slides to go? So we can just
Just two more, just one more.
all right, so just finish up so that you can take the question.
Okay, I'm sure please 1 minute.
All right, so please, if you have your questions, please just start preparing them up so that you can take them once it's done. I can see one in the chat box. So he's going to answer them. However, I want to encourage us to ask our questions on the group chat so that it can help others as well to just have an understanding of what we are discussing over the call. So yeah, thanks. Adidas, are you back?
Yeah, I'm here.
All right, please go ahead.
Okay, so yeah, we've spoken a lot about like cloud security. We've spoken about the best practices. We've spoken about how cloud security can be implemented, why it's important. But I think as people who are interested in cloud security, probably want to start a career or you have want to have the knowledge, it's very important that you know some of these trends, because these trends are really, really helping to like protect a lot of organizations. And I think it's really, really useful information for you as a cloud security engineer to know and understand. And the good thing about this is if you can understand this, you can also build robust tools. For example, if you are taking a course in AWS, Azure, GCP, or probably IBM, you see that they have different services. They have different services. But at the same time, it's not about just you just knowing those services. Okay, you know what GuardDC is used for, you know what Macy or you know what Detective is used for. It's not just about knowing that. It is about how can you put all of these tools together to ensure that the organization is secure. How can you like make use of these tools together? And this understanding this trend has also really helped me in creating things like projects, even like doing projects on the back end, because you understand these tools. You can't understand, okay, I can integrate this with this and do this with this, and then at the end of the day, it's going to really, really help. So that's why I really feel that we should add this So the first cloud security trend we might see is event-driven security. So what event-driven security does is you being able to develop security um, system that will automatically respond to like events in real time. So for example, AWS, you have events hub, right? How do you create in a granular system that once it notices any change in events hub can automatically like um create a response with this. There are so many tools and services you can use to this. For example, you can use something like Lambda. You can say, okay, for example, if something unusual happens in CloudTrail or CloudWatch, you integrate it with Events Hub here. Events Hub then triggers Lambda, whereby Lambda can probably, okay, you know what, delete that user or revoke that user's permission or delete that EC2 instance. So this is a way you can like develop event-driven security. It just includes like developing systems and developing strategies and tools that will help you to respond to security events in real time. There's so many ways of doing this. There are so many tools you can use. Like I said, Lambda, Azure Functions, SNS. So probably if you don't even want Lambda to be taking the steps for you, you want to get notification. Okay, how do I integrate this with SNS to ensure that you know what? I immediately get that notification and I can easily like respond to this event. And this is really, really good because you can easily like detect and mitigate threats. You can also like it reduces the need for manual intervention. So instead of you having to go to the console, you saying, okay, I have to log into the console today. I want to go and check all the CloudTrail logs, what is going on. Like you just like give yourself a headache. But imagine a scenario whereby you can like filter the critical, probably the medium events in CloudTrail, and that event is being sent to probably your email. So you can easily just look at, oh, okay, this event happened, this is very critical. Let me take action. That is really going to help you to be more productive than just going to CloudTrail or just going to CloudWatch and saying, or your VPC flow logs and you're just looking at all the logs. It doesn't help anybody, doesn't save time, especially if you're fatigued and you're tired. And that cloud security trend, we also have a SecOps automation. So what this does is just you're just automating your security operations, and this helps you to improve efficiency and response time. So one very good way of like adopting SecOps is, automation is by using tools and scripts to like automate repetitive security tasks. So for example, you say, okay, you know what, I'm going to integrate my SIEM with probably if you're using Splunk or you're using Sentinel. Okay, you know what? Let me integrate Sentinel with AWS, and then once there's a notification, you know what? I can easily like create an automation or a script that will do something on the back end. Probably will delete an EC2 instance, or probably that will probably help you to like add a volume or something. So that's what SecOps automation entails. And one very, very good tool that I see that helps is like AWS config. AWS config helps you to like automatically remediate non-compliant resources. So for example, if you want to maintain an environment whereby all the users are making use of like encrypted EBS volumes. So if I come to an environment and probably I'm a new staff and employee and I decide to create an EC2 instance, and then I say maybe I'm not used to putting encrypted volumes, and I say, no, you know what, I just want to create the EC2 instance. This AWS config will automatically just notice that, oh, this guy created an EC2 instance for you. This is encrypted volumes. So you can now determine your response. Do you want it to replace that instance with volumes, encrypted volume? You just want to be notified. That's what SecOps automation will help you do. So instead of you to get a notification and then you have to now be the one to now come and say, okay, let me call Adedosun. Adedosun, I just noticed that you created an EC2 instance. It doesn't have an encrypted volume. Some people would have done that easily for you, or Lambda. So that was SecOps automation use. So next, you can also, well, I'm sure this is something that is also becoming very popular. DevSecOps and rugged DevOps. They are basically almost the same thing. So what DevSecOps does for you is you integrate security into your DevOps processes, and this helps you to build secure applications from the ground up. We'll be having a DevOps session next week, so I think you can also join to at least get a view of DevOps, and you can also see how you can implement security in DevOps. So, one very common way that I've seen is by people implementing security checks into their CI/CD pipelines. So you can incorporate a security testing. So probably don't use like vulnerability scanning tools like OAuth, ZAP, but just use Sneak. Or there are so many security tools out there. You can implement the ads in your CI/CD pipeline. Also using infrastructure as code, using things like Terraform or CloudFormation to ensure that you are adhering to cloud security practices. Or using things like Chekhov. I don't know if anyone has heard of Chekhov yet. You can scan your infrastructure as code for security issues. That's where DevSecOps and rugged DevOps comes in. It's just you implementing security into your DevOps. So we can also look at security as a service. So one good thing cloud has done for us is that everything there's basically anything as a service today. There's basically anything as a service. And one really important thing you can also look is security as a service. So security as a service is where you have security solutions, where you're delivering them to the cloud. And there are so many security solutions today that are implemented in the cloud. For example, you can have like your endpoints, your EDR in the cloud. So instead of you having to like use EDR on premises where you're managing the servers, you have EDR in the cloud that you can use. You have your XDR in the cloud. You have your CASDs in the cloud. You have your URL filtering, your email security protection. Like that's a good thing in cloud security. Sorry, not cloud security. The cloud has really done. You can have everything in the cloud today. And it's really important for you to know that there's something called security as a service. And at the same time, you could also like make use of that too. And you can also integrate it into your cloud infrastructure and also your on-premises infrastructure too. So security as a service, because you're also like employing like professionals to help you too at the same time. And lastly, there's a lot of like intelligence sharing. There are a lot of benefits with security as a service too. And I think that's something that you can also look at. So it just involves using security tools that are built in the cloud and using them to secure either your on-premises environment or cloud environment. And lastly, we can't definitely not talk about AI in today's world. So there are so many ways that we can leverage AI and machine learning to ensure that threats are easily detected and their response capability. For example, one very good one, we have gadgets, AWS capability. AWS gadgets will help you like easily uses machine learning easily like identify threats, malicious IPs, and your AWS environment. So that's an example of a tool like that. Also, if you look at something like MISI, AWS MISI will help you use machine learning to identify like sensitive data. Or if you have heard of AWS Detective, it uses machine learning to also like detect things like the root cause analysis of an issue. So it is very important that we can try our best to incorporate AI to help us stay ahead of emerging threats. And this is very good because it's going to help you as an individual. There are so many things that like it's good. Like people will say, work smart and not. No, you don't have to necessarily work hard. Like yeah, you have to really work smarter. There are a lot of things that you don't have to do manually. So we don't have to say, AI is going to take our jobs. You can easily like employ AI and use AI to help you. Use AI to like develop scripts. Like for example, even if there's like a previous way of you doing something, probably there's the way you write your Terraform script. You can easily take it to AI and say, no, can you tell me a better way of writing this? And you even find like a much better way, like you let it know. So that's why AI and machine learning can really be helpful to run. This is basically the end of my presentation today. I really just want to say that cloud security is something we cannot just talk about in one presentation or in just one slide. Like there's so many things that cloud security entails from the government side, auditing, legal side. There's also the legal side of it, the auditing side of it, the detection side of like application security side of it, network security side of it, and it will not be possible to like contain all of that in today's session. I just want to end telling you that like very it is very important that we understand that the critical need for cloud security today and really need to adopt a proactive and adaptive approach to cloud security. And like I said, we regularly need to update our security practices. Also, as cloud security engineers, or if you have a cloud security interest, you have to ensure that you are staying informed about the latest security trends and technologies. Because things that are done previously will not be the way things are done. Like in the future, you have to definitely. I feel like at the point you have to then use tools like Terraform. You have to learn things like DevSecOps, because that's where the world, almost every organization uses DevOps today because of like the benefits. So there's no way you wouldn't say, okay, you know what, I really want to stay ahead of that trend. I want to find out, okay, how do I secure, how do I bring security in DevSecOps? And you also have to just ensure that you are implementing and using the right tools and solutions. So yeah, that's the end of today's presentation. I really hope it wasn't a lot, and I hope that it was really, really easy for you to understand. So I'll open the floor to questions. If you have any questions, I can easily help to explain that before the class is over.
Yeah, thank you so much, Ali Dodson. Someone has a question here. So the person says,
Okay.
which certificates exam is advisable to take as a beginner in cloud security? So what
Um,
certification would you advise?
okay,
Yeah.
so I think it depends. Like you said, as a beginner in cloud security, right? It really depends. So it depends. Do you have your CCP already in place? Do you have yeah? Do you have CCP, or it is Azure? You have Microsoft Azure already in place. One thing I'll say is you have to first identify the aspect of cloud security you're interested in. After identifying that, I try to identify the service you are more comfortable with. You feel you are more comfortable with AWS or Azure. I feel like some people will tell you, AWS is this, Azure is more used. People have their different opinions, but you find what is like easier for you at first. Once you're able to like find like what is useful for you, you can easily now like um go further and now like learn other this thing services and learn other like cloud providers at the same time. It's even very easy, honestly, because what is on one cloud provider is basically the same thing on another one. It's just that they have different names. But they are basically doing the same thing, like at the end of the day. So I think it depends basically. So that now helps you to know what exam you want to take. But and yeah, I can now like say, okay, yes, you could develop based on that. But yeah, I'll say start from the fundamentals, start from the basics, understand the services. So you can write like CCP first. Then maybe for AWS, you can write like SysOps next, system operations, because that will help you to understand like how to use some of these services and how they are used together. And then I'll advise probably like after like some years of experience, maybe like after a year and you have like been able to like do projects on your own, you can probably write the AWS security specialty. So you can just be a roadmap like that. But one thing I really advise is just get hands on. Like at the end of the day, certifications are just here or there. Yes, they help you, but at the end of the day, you getting that hands on is what really matters at the end of the day. Because it's going to like really open your mind. You know how to like talk to professionals, you understand what people are talking about. Because certification is just you read, write the exam. Without the hands-on approach, you might even forget like a lot of things you have studied. But if you have like that hands-on approach, when people are talking and easily relate to them, you can understand, and it makes the certification easy too. So when you are ready to write that exam, you will just be walking the path for you. Just know, okay, I already understand this, and you'll be walking the path. So that's I think my opinion on that.
All right. Thank you so much, Ali Dodson. Does anyone else have any question? Any question about this class on cloud security? Okay. So thank you so much, Ali Dodson, for today's section. It was really an insightful one. Um, I want to encourage us to, I mean, someone might be thinking, there's no okay, someone's asking a question. Can you suggest platform you can get hands-on experience? Okay. I think there are Ali Dodson or Tolu, which platform would you guys recommend? Free ones, okay.
Yeah, I think free one. I think Pond Lab has some like free
Yeah,
lab. You can check out Pond Lab. It has some free labs.
on
Yeah, so
labs.
your Pond Lab. Udemy can also be good, but obviously, so Udemy, you know the way Udemy works, and they always have like really do they have sometimes where they have like sales on a lot of their courses, so you can employ that and like get like they're really nice courses you can get on Udemy. For example, there's this SecOps automation course that I took one time and was really insightful. Gives you very background knowledge of how to use a lot of things. TryHack Me also used to have some labs on cloud. Yeah, but I know like for you to get like
Yeah, pay,
more advanced and experience, yeah, you have to pay to
yeah,
yeah, but yeah. So that I don't think I can just advise to yeah is YouTube. YouTube can be good too. You can go to YouTube. I remember there was a time goodness and I saw this yeah, I've forgotten his YouTube name. Probably would also can also share it on the group.
yeah,
Guy when the guy was creating a cloud, he created a home lab using Kali Linux,
yeah.
Windows. Yeah, I wasn't know the guy, but yeah, something like that. You can just
Right,
follow what the
right.
person is doing and just note it down. You see him even did it too. He's really using Terraform and using manually, so YouTube can help. And then you using like free tire, you can like get Azure the free tire, get AWS the free tire, and just try to like walk and build around things. Medium too is good too. A lot of people have posted articles like on Medium where they say, okay, how to do this, how to do that. I am Tolu is one person that like, yeah, he has like a really good Medium list. You can always check out like his Medium page and all. Like, it's always very insightful. You can see a lot of things and learn a lot of things from there. So there are people like that too that you can also just like go to Medium. So yeah, those are like some free resources. Uh,
Yeah. Thank you so much, Dodson. So, someone might be wondering, I was saying earlier, someone might be wondering, there's no hands-on labs and the likes. So the reason why we're going through this route first is to make sure we get the concept of cloud security, what it entails, and how you can get started. And that's why our next section is going to be about DevOps, and which we like DevOps slash DevSecOps. So our next speaker is going to elaborate more on what you need to know about DevOps, how to get started, and how you can integrate DevSecOps. It's going to cover all that next week. But for cloud security, I think one thing I would say is that you have to create your own path for yourself. Okay, what Adidas has taught us today, it's like a foundation. Like you basically just covered the foundation. Now it's left for you to discover what part of cloud do you want to go into, what cloud service provider do you want to learn, how what aspect do you want to dive into. So it's I encourage everyone to please rewatch this section, then ask question on the group chat that's on the WhatsApp group chat, so we can see how to help you all get started and get resources. Also, we are trying to compile some resources, so probably before the end of this week we'll send the resources out. So we are for cloud security as well, we're going to share a Google Docs that contains free and paid resources. So depending on which one you want to take to get started in cloud security and cloud fundamentals. If you're totally new in cloud, there's no problem. There's resources, free and paid resources that you can opt for cloud fundamentals, cloud security, and DevSecOps. So thank you so much, everyone, for joining. If you have any question, please just drop it on the WhatsApp group chat so that we can get and answer your questions. So thank you, everyone, for joining. Tulu, I don't know if you have anything to say. Hi, Tulu, are you there?
Hi. Yeah, yeah, I'm here.
Yeah.
No, not really.
All
Not,
right.
not really.
Thank you so much. All right. So thank you everyone for joining. See you all next week. Bye.